Hi, welcome back. I'm here with Lloyd Bock, and he is going to share with us some particular design things that are unique to the MOGAS switch valve. We're going to be focusing on the ball to stem connection and the actuator. So, Lloyd, thank you for joining us, and we're going to jump right over into the specific of this. We're going to talk specifically about the top of this valve. All right, so over here with a 14-inch 600 class switch valve. And obviously Lloyd can see this a little bit better than I can, so I'm going to step up. And what we're looking at here is the top of the valve to gearbox connection. And I really want to bring some focus to this because I think this is something that's interesting in the MOGAS design. So Lloyd, can you tell us a little bit more about this sort of assembly of the shaft to this device and the keyways and how this whole works?
Yep, sure, Evan, no problem. So essentially what we've done is we take a shaft directly from the valve shaft straight through the stem adapter. You can see here's the stem adapter over here, and the shaft rises up straight through that hole. But at the end of the day, it's connected directly to the valve shaft. So off of this indicator shaft, we'll put a striker, and around the perimeter of the gearbox, you'll have your individual proximity switches. So you'll typically have one for your mid-travel, for your bypass, and for drum A and drum B. So you're directly driving off of the valve stem. There's no chance for hysteresis or any repeatability issues. You hit the mark every single time.
And so just to clarify for those, it took some explanation for me as well. This lever that's moving around, right? In other designs that you may be more familiar with, that proximity switch array that we've all seen before is being located by some sort of attachment that rides on one of these bolts, right? And the bolts rotate as the gears drive, and they rotate as the actuator drives this whole assembly, but it doesn't actually necessarily indicate what's happening with the ball.
Correct. And on top of that, if one of these bolts comes loose, then you pick up more hysteresis on that switch target. If some of the bolts fall out, they come out, they loosen off, and that target happens to fall off or not be put back on, then you have problems again with indication. Mm-hmm. Valves not stopping on port where they need to, and all sorts of other issues in a coker.
That would never happen.
Never.
And I think why I wanted to bring this to everyone's attention is that, unfortunately, we in coker land are very good at breaking things. And, we've had stem shear, and this is why during a lot of our trainings at the conference and in the field, we like to reinforce the fact that the operators need to physically look at the stem and make sure that it's moving and make sure that it ends up in the spot that it needs to be. So I think this is sort of a natural segue. Let's jump over to the ball itself, and we can see how that assembly actually looks disassembled.
Yeah, perfect.
All right, so we're back. With the magic of editing, we have relocated in front of two switch valve, ball valve internal parts. And I wanted to give Lloyd the opportunity to discuss with us some of the sort of unique MOGAS design features of this assembly. And for those of you who are familiar with ball valves, you'll notice that there's something very unique going on here. Take it away, Lloyd. What's that?
So what we've done is we machined the stem and the ball out of one solid piece of material. So again, you've got no mechanical connections. It's a solid piece of material, no chance for hysteresis again. And on the top of this shaft is where your indicator for your limit switch is located.
So that indicator we saw a second ago, right? Just comes
correct,
right here. And so if that thing is installed right, it is going to point exactly where that opening is every single time.
Correct. And also if the indicator is turning, the chances that your ball are turning is highly, highly likely.
Okay. So let's talk about, I don't know if we spent too much time over there talking about what's going on with these two machine grooves in the stem.
So we'd insert two keys into those grooves, which would then locate onto the stem adapter, which we showed in the previous section. So you've got a failure point here potentially to protect the valve. You've got two dowel pins from that stem adapter to the locking plate, and then you've got two keyways into the actuator gearbox as well. So you've got multiple areas and ways to protect the valve stem against any chance of shearing.
So it's sort of the belt and suspenders concept.
Correct,
We're good in coker land at breaking things, so we design it to be strong. I don't know if there's anything else specific we need to bring attention to. Maybe I'd just like to bring one other little attention. This is an interesting design detail that's maybe only visible in the factory, but there is a machine mark right here in the dead center indicating the position of the ball. So not only can you locate the position of the ball using the keyways as sort of a macro check, you can also have this little micro check going on, and there'll be a match marked one on the valve body itself as well.
Correct, yeah. And we do the same thing with our two-way ball valves as well with the C series. There's a stamping on the top of the stem that shows the direction of the ball.
Well, I think this is, again, one of the unique design aspects of it. So I really appreciate MOGAS taking the opportunity to share with us, how they do things in an assembled and a disassembled way, because it's, something special you don't get to see at the conference. But if you would like to learn a little bit more about how they do their designs and some of their design experience, I welcome you to join us at RefComm and talk to our friends at MOGAS and all the other exhibitors and vendors that will be at the show. So look forward to seeing you soon. Thank you, Lloyd.
Perfect, no problem.